All right, so we're going to talk about Cramer's rule, and we're going to only do two variable systems of equations. Now, that's a regular linear system, correct? You could solve this system and find the xy ordered pair by doing substitution, elimination, and or graphing. Do y'all agree? Okay. Now, since we're talking about matrices, I'm gonna show you how you can use the determinant and matrices to actually come up. So it's another method for solving a systems of equations besides substitution, besides elimination, and besides graphing, which, by the way, is my least favorite of those three. So the coefficient matrix is important, all right? So notice how my system is lined up. I have a column of x's, a column of y's, and a column of constant numbers. The coefficient matrix is the 2 by 2 that goes with the x and the y. So the coefficient matrix is 1, -5, -7, and 2. I pulled the coefficients from the variables. Now, 9 and -30, those are constant numbers because they have no variable attached. Okay? Now, when we start doing Cramer's rule, we're going to have to take the coefficient matrix and find the determinant of that. Okay? So it's important that you do that part first. So, Cramer's rule, named after the Swiss I can't say that word, Swiss mathematician, uses the coefficient matrix and determinants to solve systems of linear equations. I wouldn't, but some of y'all would. If you didn't have anything else to do, it wouldn't. All right. So we're going to solve the systems of equation by using matrices and determinants. Okay. So given the 2 by 2 system, we're going to let matrix A be the coefficient matrix, which we just talked about. And as long as the determinant does not equal to 0, you can move on. Okay? So if your determinant is a 0, then you don't have a unique solution. But unique solution, xy. Well, how are we going to calculate xy? Well, to calculate the x coordinate, you're going to do this determinant divided by the coefficient matrix determinant. Notice that both x and y have the same denominator, but they have different numerators. Y'all agree? Okay. So first thing we're going to do is we're going to find the determinant of the coefficient matrix. All right. Now, the way this works, and I'll show you as we go through a couple of these examples. Here's my coefficient matrix. Now, when I am solving for x, I am not allowed to use the numbers attached to x. So A and C are off limits. Well, I have to have numbers to put in that spot. So what I'm going to do is I'm going to grab these two numbers, put them in here. Notice E and F are first where the X's used to be, and then I keep my Y values, B and D. I cannot use the numbers attached to X when I'm solving the numerator for X. Y is the same way. When I move over to solve Y, just the numerator, I cannot use the Y values, that B and D number attached to the Y. So I'm going to grab E and F. I'm going to slide those over. Notice how I have A and C. I have my X column, and then I filled in the gap with the constant numbers. Okay? Now, that's only for the numerator. All right? So, first thing we're going to do is we're going to find the coefficient matrix, and we're going to identify the determinant, because that decides whether we keep going or not. So what we're going to do is we're going to find the value of the denominator. If it's not a 0, we're good to go. If it's a 0, you stop. Okay? If the determinant of the coefficient matrix equals to 0, it does not have a unique solution. It's either no solution, meaning the two lines are parallel, or it's an infinite solution, meaning you have two equations that represent the same line. What we're shooting for is two lines that intersect, and I want that XY point. That's what I want. If my determinant of the coefficient matrix is not a 0, that's what I get. Okay? So we don't want 0 in the denominator, period. So what we're going to do first is I am going to list that coefficient matrix, which we did just a minute ago, 1, -5, -7, and 2. And I am going to find the value of the determinant because that is my denominator for X, and that is my denominator for Y. I cannot put a 0 in either one of those denominators. Okay, so that's 1 times 2 minus -5 times -7, which is 2 minus 35, which is -33. I can keep going because my denominator is not a 0. Everybody okay with that? All right, now I need to set up the 2 by 2 determinants for the numerator. When you are solving for X, when you move to the top part of the fraction, you cannot use the X numbers. What are you going to put in the place of those two X numbers? 9 and -30. And then I fill in my Y's, my -5 and my 2. I'm going to find the value of the determinant, 9 times 2 minus -5 times -30. That gives me 18 minus 150, which gives me a numerator of -132. Now, that divides flat out to 4. -132 divided by -33 is 4. All right, so my X value is done. When I move to the numerator of my Y's, I cannot use any number attached to Y. So I am going to list the X numbers, so 1 and -7, and I'm going to use my constant numbers to fill in the gaps for the Y numbers that I cannot use in the numerator for Y. Then I'm going to do my determinant, 1 times -30 minus 9 times -7. That gives me -30 plus 63, which gives me a numerator of 33 divided by a denominator of -33, which is -1. Now, if you solve that by substitution, if you did elimination, or even if you graphed it, that would be the outcome. So now you have a different method for solving a system of equations using matrices and determinants. Okay. Number 2. First thing I need is I need the value of the determinant because that determines whether I keep going or not. That determines my denominator. As long as I don't get 0, I can keep going. So the denominator is the coefficient matrix. So your X values and your Y values. That would end up being 2 minus 30. 2 times 1 minus 30. So -28 is my denominator. Now, I'm going to set up my determinants for my numerators for X and for Y. When you solve for x, you cannot use the values attached to x. So I'm going to put my constants in that first column, grab my y values. I can use those. That would be 38 times 1 minus 6 times negative 3. That's a grand total of 56. So 56 divided by negative 28 is negative 2. How would I set up the numerator for the y coordinate? Can I actually use the 6 and the 1 for y? Yep, 2 and 5, and then replace those y numbers with the 38 and the negative 3. So 2 times negative 3 minus 38 times 5 gives me a grand total of negative 196. And when you divide negative 196 by negative 28, you get positive 7. Now, if you're not sure if those numbers are right, you can always say 2 times negative 2, which is negative 4, plus 42 should give me 38, and it does. Negative 10 plus 7 does give me negative 3. So when I plugged these two numbers in for x and y into both of the original equations, it balanced. All right, so I'm going to pause, and you get to do number 3. I will tell you that there is a solution. You do not get lucky. You do not get a denominator of 0. Negative 3, negative 4. Everybody good? All right, so it's not that bad. It's a little bit time consuming, but it could be worse. Okay, and I'm about to show you worse. I am going to turn off the video because I don't want to scare the people that haven't seen this yet.